Yeah, so there's a couple of differences about our solution compared to other predictive maintenance or predictive quality solutions out there. One would be we are able to detect long-term dependencies because we use a combination of neural networks. Most or typical AI solutions are only able to detect, like, if something immediately was changed, the immediate impact. Then we also already did more than 20 machine learning and AI projects out there, so we're already very experienced and have a very experienced team when it comes to that. And we are trying to do explainable AI, meaning that when we work on solutions or when we actually do the visualization to explain why the AI is suggesting something so that you can actually trust the AI and its decision. Yes, one of our application fields is predictive maintenance. And we have a use case, or brought a use case with me in the Vienna district heating network, which is one of the biggest district heating networks in Europe. And they have so-called converter stations that cool down the temperature from approximately 130 degrees to 90 degrees before it goes to the household. And there are 8,000 of those converter stations, and you can imagine they're machines as any other. They have downtimes and break down. What we tried to do, or what we did, is we used historical data in order to predict 7 days in advance when a downtime will happen. And we were actually able to detect 91% of those downtimes 7 days in advance. And I can show you now the solution on the screen. So this is the dashboard that we built for them. You can see there are 3 that are currently at risk of a downtime. You see that there's currently 6 scheduled maintenance works. And here you have a map of Vienna with all the stations, and you can see that the red one is at risk of a downtime. And we have a closer look into it, and we see what's going on, what's currently wrong, how the normal distribution of a temperature and pressure should look like, and what's the current status, to also give some indications of why there is a problem. And we also have applications in the predictive quality area. So for instance, in the brick production, you have several production steps, but the quality inspection only happens at the very end of the production line, which and the problem about this is they don't know what happens during the production, what influences the quality at the end. So their goal was to reduce scrap costs. We took the data from the machine and the data from the quality data at the end, put them in an algorithm, and based on that we could see which parameters do we need to change in order to reduce scrap costs. And we work with companies in all different industries. We work in the automotive industry. We already did projects with Audi and with Mahle. We also work with machine manufacturers like Andritz. In the energy industry, I already mentioned Wien Energie, but we also work with the Vorarlberger Kraftwerke. And since we make tailor-made solutions, our approach can be applied in any industry. And thank you for listening, and thank you for the interview.